In this video, we solve a problem from differential equations according to the method solvable for x. And again, this problem is very important problem for 10 mark section. Let us see the problem. Solve y square log y is equals to xpy plus p square. Solve y square log y is equals to xpy plus p square. This problem is very important problem for 10 mark section. So right, it is the given equation number 1. The given differential equation can be represented by equation 1. Now you observe that this equation involved in three variables x, y, p. This equation involved in three variables x, y, p. What is the degree of x? 1. What is the degree of y? 2. What is the degree of p? What is the degree of p? 2. But maybe degree of this p is greater than 2 also, because if you expand the logarithmic function log y in a series form, you get higher degrees for y. But anyway, primarily we observe that the degree of x is 1. So clearly differential equation is a linear differential equation in x. Equation 1 is a linear differential equation in x. So if it is linear in x, it means the degree of x is equals to 1. So it can be solved for x. It can be solved for x. Yes, the equation 1 can be solved for x. If you write equation 1 can be solved for x, then you have to shift all the terms to the right side except x. You keep x in the left side. You must keep the variable x in the left side, and the remaining all terms to you must shift into right side. So equation 1 can be written as xpy is equals to y square log y minus p square. X is equals to, by dividing with py, y square log y minus p square by py. Again, y square and y get cancelled. Y by y log y by p minus p by y minus p by y. Here it is. By separating the terms, we get this step. Here you observe that y square log y divided by py. Y square log y divided by py. Y square and y get cancelled. You get y log y divided by p. And the second term minus p square by py, you get only minus py. Let it be equation number 2. Now differentiate equation number 2 with respect to y. Remember that this equation is solvable for x. This equation is solvable for x. If the equation can be solved for x, then you have to differentiate that equation with respect to y. You have to differentiate the equation with respect to y, opposite variable. So now you observe that. So differentiate equation 2 with respect to y. So we get this step dy by dx, dx by dy is equals to d by dy of y log y by p minus p by y. What is p? P is equals to dy by dx. P is equals to dy by dx. What is 1 by p? 1 by p is equals to dx by dy. 1 by p is equals to dx by dy. The left term is same. Dx by dy. Dx by dy is equals to 1 by p. Dx by dy is equals to 1 by p. Now split the differentiation. D by dy of first term minus d by dy of second term. Now apply the differentiation derivative of u by v rule. What is the derivative of u by v? We know this d by dx of u by v, d by dx of u by v is equals to v into du by dx minus u into dv by dx divided by v square. Please observe the formula. D by dx of u by v is equals to v du by dx minus u dv by dx divided by v square. So by applying this formula to both the terms, from the first term we get this p into, from the first term we get the first flower bracket term, p into dy by dx, p into d by dy of y log y minus y log y into dp by dy divided by p square. From the second term we get this y into dp by dy minus p by y square. Again here d by dy of y log y, d by dy of y log y, uv rule, derivative of uv rule, d by dx of uv, d by dx of uv. What is the formula? Du by dx into v plus u into dv by dx plus u into dv by dx. That's it. So by substituting that uv rule, we get this step. 1 by p is equals to, by substituting uv rule, 1 by p into log y plus y into 1 by y. You get here 1 by y because derivative of log y is 1 by y. Minus 1 by p square y log y into dp by dy minus 1 by y dp by dy plus p by y square. I split the terms. Please observe that. Here p by p square, what you get? P by p square, what you get? 1 by p. Here y log y by p square. Y log y by p square. Here y by y square. I split the completely terms. So we get this one. 1 by p is equals to 1 by p into log y plus 1 y into 1 by y minus 1 by p square y log y dp by dy minus 1 by y dp by dy plus p by y square. Here y get cancelled, you get 1 and multiply with 1 by p. So finally we get this term. 1 by p is equals to 1 by p log y plus 1 by p minus y by p square log y dp by dy minus 1 by y dp by dy plus p by y square. Here you observe that in the left side and in the right side we have plus 1 by p. So it get cancelled. It becomes 0. They 1 by p minus 1 by p is 0. So they get cancelled. And you have to observe that. Here from these two terms, I mark the terms. Please observe that. Minus y by p square log y dp by dy minus 1 by y dp by dy. Minus dp by dy is the common term. By making minus dp by dy common, from this term we get 1 by y. And from this term, we get y by p square log y. What are the remaining terms? 1 by p log y and p by y square is equals to 0. That's it. And in the next step, I remain the first term as it is. The first term as it is, I remain that term. And from the second term, I make common p by y. By making p by y common. If you make p by y common, from the second term, we get 1 by y. If you make p by y common, then from this term, we get 1 by y. We get 1 by y. But here in this term, there is no p by y. There is no p by y. So that p by y becomes y by p as multiple for that term. There is no p by y term in this term, but we are making common p by y. So the reciprocal of p by y means y by p becomes multiple to this term. Y by p become multiple to that term. So that term becomes y by p square into log y is equals to 0. Now you observe that the in terms are same. The in terms are same. 1 by y plus y by p square log y. Here 1 by y plus y by p square log y is the common term. By making that common term, we get p by y minus dp by dy is equals to 0. From this expression, we get two equations. The first one is 1 by y plus y by p square log y is equals to 0. Equation number 3. And p by y minus dp by dy is equals to 0. Equation number 4. Observe that equation 3 is rejected. We cannot use equation 3 because it gives a singular solution. It gives only singular solution. What it means? Equation 3 is independent of dp by dy. Equation 3 is independent of dp by dy. So we eliminate equation 3. We cannot use equation number 3 because it is independent of dp by dy. It is independent of dp by dy. It is independent of dp by dy. That's why it gives a singular solution. That's why it gives a singular solution. Right? Now equation 4 implies. What is equation 4? Here you observe that. This is equation number 4. P by y minus dp by dy is equals to 0. Now equation 4 implies dp by dy is equals to p by y. Separating the variables, dp by p is equals to dy by y. On integrating both sides, we get that step. Integral 1 by p log p. Integral 1 by y log y plus integral constant log c. Log p is equals to log yc because log a plus log b is equals to log ab. Logarithms get cancelled on both the sides. P is equals to yc, where c is arbitrary constant. Eliminate p from equation 1 by using this equation 5. Eliminate P from equation 1 by using equation 5. So replace P by YC in equation 1. Replace P by YC in equation 1. We get this equation. Y square log Y is equals to CX Y square plus C square Y square. You observe that Y square is common in 3 terms. So it get cancelled. Y square get cancelled. Log Y is equals to CX plus C square. Therefore, general solution of equation 1 is log Y is equals to CX plus C square, where C is arbitrary constant. Again, this problem is very, very important problem for your end semester examination, especially for second section, means for 10 mark section. Wish you all the best. Keep learning.